Hello everyone, welcome back to another lecture on the course Python Fundamentals, Building Block for Aspiring Developers. We will continue with the seventh module, that is Object-Oriented Programming. According to our agenda, we are on the 26th day. Today we will discuss about constructor method and instance variables versus class variables, as well as the concept of abstraction. So let's begin. So constructor. So the constructor method is called this underscore underscore init underscore underscore underscore. This is the one that we looked at in the previous video. You saw me typing it, but I told you that I would explain it to you in the next video. So in this one, we'll have a look at this. So what it is that it is a kind of a special method. You can say function, but the correct terminology is method. So I would try and keep to that one. So it is a special method. Why is it special? It's that whenever a instance or object of a class is created, this function gets called automatically. We do not need to call it specifically. It just gets called whenever we need to, whenever we create a new object of the class. Okay. Now, why it is important? It is important because sometimes whenever we need to create, let's say, um, something based on a blueprint. Okay, we need to create an object based on a class. We want some things to be already initialized because let's say these are the default values, or that blueprint or that object, if we represent it in a real world, if some of the things that are not there, we cannot have the object. For example, a car. If we have a car in real world, it is not possible for it to have no color. I mean, it's simply not possible. It will have a color, even if it's old car, the color is fading away, but still the car will have a color, right? Red color, blue color, black color. You cannot have a car with no color. That is simply not possible, right? So what we want to do is that instead of first creating an object and then giving it um, a color, that is not very feasible. So what we do is that we define this methodology of giving a color to the car in the constructor method. So whenever we create a object of the class car, we will have to assign a color to that object. Okay, because again, it's simply not possible for us to have a car without any color. Okay, we will look into this into much more detail. So now let's quickly have a look at the difference between variables. So there's two types of variables. First is the instance variables. So instance variables are unique to each object, as we discussed in the previous one, that if I have two objects, the first object cannot have the value of uh, of a variable of second object, right? For example, car 1 and car 2. If I say brand, car 1 cannot have a brand of Honda. Car 1 will always have a brand of Toyota until and unless I change this brand myself, right? So they represent the object's state or characteristics. In the previous one, we saw the examples of both of this. So characteristic would be the model of the car, the year of the car, name of the car. The object's state would be that is the car moving? That is what we saw. So this is also used to keep the track of the object's state. So again, the first object can only keep track of its own state, not of the second one. And they are defined inside the init function, init method using the self keyword, um, and they can also be used within the class. All right. Now, we also have class variables. So class variables are like shared variables amongst all instances of the class. Okay. For example, I have wheels. Okay. All the cars will have four wheels, let's say. I'm just talking about everyday cars. I made make a class that is kind of a blueprint of the cars. So we know all the cars will always have four wheels. So I say wheels is equals to four. Okay. So now all the objects can access this variable, but that is the same variable that is being accessed by each of them. If I change something using the first object, it will be changed for all of the objects. Okay, and they are defined outside of any method inside the class. Okay, as you can see, haven't written them in the constructor method. I've just written it outside of that one. And now let's understand the concept of abstraction. So abstraction is the process of simplifying complex systems. Okay, it is that we just focus on essential aspects and we hide the unnecessary details. Either they are unnecessary or either we do not want to show them to the user. So in context of OOP, it involves creating classes that represent real world entities and only exposing relevant information. Okay, so for example, you have a let's say a long method that is using let's say 4 or 5 sort of um, class class variables or attributes, but you do not want to show all the attributes to the user. You just want to show the function. So you just create the function and user is not able to access the attributes. Okay, so this is how abstraction works. So again, what it means is that you want to hide some detail from the user, either because it is unnecessary or second because you do not want to show them due to any reason. Okay, so let's start coding and have a look at this. So let's go to VS Code. I'm in the same file. I've deleted previous ones. So from the previous lecture, let's create this time around, let's create a different class, dog. Okay, dog is a physical being, physical object. Let's say not an object, just a living being, but let's say object. So dog is something physical. We can model it because a dog has attributes and methods. Attributes could be the breed of the dog, age of the dog, color of the dog, name of the dog. And the methods could be walking, barking, sleeping, these sort of things, the actions that they perform. So in the constructor, what we want to do is that we want to say init this, and we always have the first here you can say argument called self. Again, self is used to tell that okay, this is part of this class in which it is defined. Okay, so let's say we want to give our dog some attributes. Okay, so I'll just get rid of this comma for now. So let's say my dog has a, or even any dog has, let's say, a color, right? And then they also have, let's say, an age. Okay, and let's say they also have, what do you say, let's say if they are pet or not, is pet. Okay, so what I want to do is that whenever I want to create a dog, dog1 is equals to dog. A dog will always have a color, age, and we can always tell if it is a pet or not. Okay, so these things need to be initialized as soon as we create this object of a dog. Okay, so this is why we create this constructor function. So here we say okay, color we will get from here, age we will get from here, and p we will get from here is pet. So we say is color is equals to c, okay, age is equals to a, and is pet is equals to p. Okay, now when we create the object in this parentheses, we have to put in these things that we are passing to the constructor method. Okay, we simply ignore the this self keyword, we don't count it. So this means that it has 3 arguments or 3 parameters, so we need to put in 3 parameters. So the first one, c, is going to the color of the dog. Okay, so first one we need to put in color, so let's say brown. Okay, the second one is going to the age of the dog, so let's say our dog is 1 years old. Let's say is it a pet or not, we say true, this is a pet dog, right? So now whenever we create this dog, all these things are already initialized because of this. We haven't called this function, we haven't done anything like um, dog dot, like we haven't done anything like this. Okay, this is kind of like calling a method, but we haven't done anything like this. Okay, simply create the object and pass in these values. This method is already called. Okay, now if I say print dog1 dot color, save it, we get the color brown. Okay, now if I don't have any of these, let me create another one because I don't want to change this. So let's say this over here. Let's say we have defined these things, okay, but we haven't given them a value. So first of all, this will show an error. So I need to comment it out too. Let me just copy this first like this. Dog1 is equals to this. And if I run, so it says dog has no attribute color because we haven't defined anything. Okay. So this is why we need to initialize these variables or these attributes. Okay. And here we need to provide these attributes. So whenever this object is created based on these values, this is already initiated. Okay, fair enough. Now I can even create another function, uh, indentation problems. Okay, so let's say bark and we say self and we say print dog is barking, then we say dog1 dot bar and run the code. Says dog is barking. This prints none because we are putting this in a print statement, whereas this method is already doing a print and returning nothing. This is why it prints none, but you get the point. Okay, so this is how we use constructors. Now let's have a look at the class variables and instance variables. So these variables right now are instance variables. Okay, if I create another dog, let's say copy this one, and let's say it is not a pet and it is, let's say, white in color, and we say it is a second dog. Okay, and we say dog1 dot color, and we say print dog2 dot color, and then we run the code. So both of them are different, even though we are referring to the same variable, same name of the attribute is the same, but since these are in different objects, each of them are linked to the object. So the value of the attribute for this object is different as compared to this one, so they will always be different. So these are instance variables. But let's say we have a class variable. So the class variable would be that legs. So it has 4 legs. Okay, so we say, okay, dogs have 4 legs, right? Now if I do print dog1 dot legs and I do print dog2 dot legs, it should be the same, 4 and 4, because this variable is now a shared variable amongst all these. Okay, dog1 and dog2 are referring to the same variable. These are not differently, these are not stored separately. Okay, if I make changes to any of these, it will be seen in the other one. So for example, I say, okay, both of them are 4. I say dog1 dot legs is equals to 3. Okay, now let's go ahead and print out and see if it changes for the other one as well, right? So run the code. So first it says 4 4, and for the second one it does not say this. Okay, because again this legs is different for both of them, but it is a variable that is common in all of them. Okay. So this is why we have these class variables. These are mostly not used, but still it's good to know the difference between these two. Okay. Now, if I talk about abstraction, let's say we have someone who is using this. Let's say you created a program for someone, and in the backend you created some classes for dogs, and let's say we say define um, print dog color, and I say self, and I do, or instead let's say date dog age, right? And now the methods can also have these parameters or arguments, just like normal functions work. So I would say self dot age is equals to new underscore age. Okay. So now let me get rid of this one. And I want to say print dog one dot age. Okay. Then I want to say dog one dot update dog age, and I want to give it maybe 2 because after a year the age has been updated. And now I say dog one dot age. I need to put that in a print statement like this and the code. So now first the age is 1. Now we have updated it and the age is 2. But what is happening is that whenever the user calls the function update dog age, user can only provide a value that updates the age. This function cannot update the color of the dog, cannot update the status if it is a pet or not a pet. So this is kind of how abstraction works. Now I've been using the variables directly. Like I've been using dog1.age, dog1.age or dog1.color, things like that. But this is generally not used. Okay, this is not a good practice. So what happens is that to get something, we say define get color, okay, self, and it will simply say return self.color, right? So we define these get functions, let's say, for each of these attributes. This is like a good practice. We define these as functions, okay, and we say return self dot age, and I want to say age, okay. So instead of getting the age like this, what I would do is that I would say dog1 dot get age, okay, dog1 dot get age, okay. I'm not directly accessing the attribute, but I'm accessing it through a function. So what it does is that I haven't defined any attribute to get the pet status, okay. So the user cannot use any of these at any of these methods to get the status of the pet. Only you know the how the class is made, so you can put it here. But if someone is using your let's say this class and they're not familiar with the structure of the class, you only tell them about the methods that they can use. You do not tell them about the attributes or these um, let's say these state variables which check the state of the object. They cannot use it, so this kind of provides a abstraction. This means that they cannot access it. You provide this function, you provide this abstraction yourself because they might not need it or they might change it. It is an important thing, so you do not want to allow the user to change this sort of things. Okay, so this is how the constructor and variable types work and how abstraction works. So that was all in this lecture. Again, I'm saying that Object-oriented programming is kind of a different paradigm. It may seem a bit complex right now when you're studying, but once you start practicing it, once you start relating it to real world objects, real world examples, then it will become much more easy to you. Then you will start understanding it much more. This is why I strongly recommend and suggest that you guys keep on practicing about it. Look at some real world examples that you can create classes of. Put in some methods that you want. Try and see how you can do abstraction where it is needed and put that in code. Once you do this, object oriented programming will become much more familiar to you and you will start becoming good in that one. Okay? So having said that, this brings our lecture to an end and we will see you in the next one. Up till then, goodbye.